These notes are on finding the surface area of triangular prisms. Before we start, let's review again the definition for surface area. Surface area is the area of all faces of a three-dimensional figure. Yesterday in class, we focused on finding the surface area of rectangular prisms, which had a total of 6 faces. Today, when we find surface area of triangular prisms, we are only finding the area of 5 faces, because a triangular prism only consists of 5 faces. So we have our table kind of like we did yesterday, where our 5 faces have been labeled. A triangular prism consists of 2 triangles and 3 rectangles. Since surface area is the area of all faces of a 3D figure, I need to find the area of all faces of this triangular prism. So first we're going to start with the triangle, and I'm going to outline that in blue so that I can tell them apart. Remember, surface area is covering the entire surface. So I'm going to sketch what that looks like. Here's 7 millimeters as my base, and my height is 4.5 millimeters. I know that that's my height because I can create a right angle here in that figure. Let's remember, when we're finding area of a triangle, what our formula is. To find area of a triangle, we multiply base times height and divide by 2. My base is 7, so I'm going to replace b with 7. My height is 4.5, so I'm going to replace height with 4.5. And then, since it's a triangle, I'm going to divide that answer by 2. So I need to calculate the area of that face. So when I multiply and then divide by 2, I get 15.75 millimeters squared, because area is calculated in square units. The nice thing about triangular prisms is that since the triangle is our base, I know the other triangle is going to be congruent. So my sketch for the other triangle should be exactly the same, which means my dimensions are the same, which means my area is the same. So when I'm looking at this figure, this back triangle is congruent. It's the same exact size as the front triangle. So the 2 triangles have the exact same area. Now the tricky part is the 3 rectangles. Sometimes they're hard to see. So I'm going to do each rectangle separately so that I can get the right dimensions. So first I'm going to look at this rectangle that's formed at the bottom of this figure. I'm putting that in yellow. So the first rectangle I see, I need to sketch, because it's at the bottom of that prism, and its dimensions are the 7 is here and 10 is here. So it's 7 millimeters by 10 millimeters. A rectangle has its own area formula, and that is length times width. So I'm going to substitute these in. So the area of this rectangle is 70 millimeters squared. So right now I've completed 3 faces out of 5. I've got 2 left. I know the other 2 are going to be rectangles, so I'm going to look at my picture and find those. So the other rectangle I see is kind of on this side here. So I've made that orange. And I'm going to try to figure out what the side lengths are. So if I look at this bottom length right here, I'm going to look and see what's parallel to it so I can figure it out, just like we did yesterday. This side is the same as 10 millimeters. So this side over here is also 10 millimeters. Then I need this side up here. It's common to want to use this 4.5 because it looks like it's on that side, but the 4.5 is the height, which is in the middle of this triangle. So the only other measurement that this could be is 6 millimeters. So my orange triangle is kind of on the side, is going to be 6 millimeters by 10 millimeters. And for area, since it's a rectangle, it's length times width again. So my two dimensions are 6 and 10, which makes my area 60 millimeters squared. Usually when I get to the last rectangle, it's the hardest one to find, but there's still one rectangle that I have not looked at. I've got my two triangles, I've got this rectangle at the bottom, and I've got this rectangle at the side. But there's actually another one that's over here. Again, sometimes it's hard to see once you get to that fifth face, so I can kind of outline it again in this color. So the last rectangle is over here, and its dimensions are 10 and 6. So again, I have another rectangle of 10 millimeters and 6 millimeters. I find the area the same way. 6 times 10, and that's 60 millimeters squared. We were lucky in this problem that two of the rectangles were exactly the same area, and the reason that happened is because our triangular prism was made up of an isosceles triangle at the front. That will not always happen. The two triangles will be congruent. We got lucky in this problem that the two rectangles are congruent. That doesn't always happen. So now that I have all 5 areas, we're going to answer the questions at the bottom. How can I use the information from my chart to determine the surface area of the triangular prism? If we're following with what we did yesterday, what I need to do is I need to add all 5 areas together, because I have 5 faces, to determine the surface area. So all of my measurements, all 5 areas, I have 15.75 times 2, because I have 2 of those, plus 70 plus 60 times 2. Because I had 2 of those. So now I can add these together. This would be 31.5 plus 70 plus 120. And my final surface area is going to be 221.5 millimeters squared. So very similar to what we did yesterday. Only difference is that I have 5 faces instead of 6, and 2 of them are triangles. 2 of them are triangles. So that's surface area of a triangular prism. So what you're going to do now is flip to the other side, and we're going to label these problems. So this is going to be problem 1, problem 2, and problem 3. So you're going to calculate the surface area of these figures. Notice I've given you 5 boxes. That's because you have 5 faces in this figure. You've got 2 triangles and 3 rectangles. So for every triangular prism, I should have 2 triangle area, 3 rectangle area, and I add them together to get the final surface area. So go ahead and practice these 3 problems and then submit your responses.